This is Module 9, Lesson 5. We are going to return to using moles now as we work with empirical and molecular formulas. So we saw the definition of empirical formula quite a while ago. I don't even remember what module off the top of my head. I'm thinking like Module 7 on covalent compounds. An empirical formula, remember, is the whole number ratio of a compound. If you can read my handwriting there. So for example, if we had CH12 is not an empirical formula because they could be reduced. You could reduce that down to C with an understood 1, H2O. They are all divisible by 6. This right here is an empirical formula. This is a molecular formula. It is a multiple of that. And so I believe it was Module 7 back when we first did this. So what we're going to do now is we're going to use the percent compositions to find an empirical formula, and we're going to have to use moles to do this. So I have the steps right here for you. Number 1 says write the percent as a gram. What we're doing in order to make this work is we are assuming that we have a 100-gram sample. So if you have 20% of 100 grams, you would have 20 grams. So we're simply going to take the percentages and write them down as grams. Then step 2 is that we're going to convert the grams to moles. This is the mole step that we've learned in this module. You should know how to convert grams to moles using molar mass. The third step then is that we're going to pretend that the number of moles are the subscripts. So for example, if we end up with 2 moles of carbon, then that would mean C2. So the moles are going to turn into our subscripts. Now there's a small problem here. If the number of moles are decimals, we cannot have like 1.5 carbon atoms or 0.5 carbon atoms. So if the number of moles is a decimal, you're going to have to do step 4, which is to divide all of the numbers by the smallest number, and that hopefully will make them whole numbers. And I know you're probably thinking, do what? Like, just wait till we get to an example, and then you can come back to these steps if necessary. And then this may be in step number 5. If you end up, like if you do this division part and you still end up with a decimal, you may have to multiply at this point to make whole numbers. So on step number 3 here, most of the time you end up with answers that aren't like whole and half numbers. They're answers like 1.14 or 2.63. Like they're decimals of all shapes and sizes. You almost always have to do step number 4. And I would say that 9 times out of 10, when you do step 4, you will end up with whole numbers at the end of it. Every once in a while, though, after you divide, you will end up with answers that end in like 0.25, 0.3, you can have 0.5, 0.67, or 0.7. Okay, if you end up with an answer that is 0.25, it will be necessary to multiply by 4 to make it a whole number. A third, a 0.3, it will be necessary to multiply by 3. If you end up with a half, you're going to multiply by 2. 0.67, you will also multiply by 3 to get a whole number. And 0.75, you will multiply by 4 to get a whole number. Most of the time, you end up with this right here. But it's not uncommon to see something else. I'm going to work a problem for you that ends after step 4, and then we're going to work another one that ends after step 5. So you're going to need your notes and practice sheet in order to do this. If you don't have it, that's fine, but then you're probably going to want to copy down the example problem that I do, mainly because it helps to look back at your work. So this is your first example problem on your paper. It's in a box that says this right here. So we follow those steps that I set out for you before. Step 1 said write the percents down as grams. So what we're going to do is I'm going to write 40.2 grams of potassium and 26.9 grams of chromium and 32.9 grams of oxygen. That was step 1, is just to turn the percents into grams. Now, step 2 was convert these to moles. This is an old problem. We need to do a short problem. we need to put grams on the bottom and moles on the top. Now, how am I going to get these numbers? Just like we did before. I'm going to use the molar masses off the periodic table. Potassium's is 39.1, so there's 39.1 grams of potassium in a mole of potassium. We do the math for that. Now, my calculator says a lot. My recommendation here is to write this down with 2 or 3 decimal places. I mean, more is certainly better. I usually give 2 to 3, and honestly, sometimes I alternate between giving 2 or 3. So this one I wrote down 0.03. And I'm going quickly. I've already done the math for these. Okay, chromium on the periodic table has a mass of 52.0. We're still rounding it to 1 decimal place. I've asked you in the past. You do this math problem, you'll get, I wrote on my paper 0.517. I wrote 3 decimal places. I'm not really sure why, but it's what I did. It's fine to do 2 with this one, 3 with this one. Oxygen has a mass of 16 grams per mole. And when we do for that one, we get, I wrote down 2.06. That means skip ahead. So, okay, our step 3 was use these numbers as your subscripts, unless they're decimals. So I cannot use scripts as this. If we tried to do this right now, we would have K1, CR half, and O2. I cannot have half of a chromium. So the easiest way to proceed from this point forward is to divide by the smallest number. My smallest number is this one. So I'm going to divide everything by 0.517. Okay, so obviously 0.517 divided by 0.517 is 1. When you divide 1.03 by 0.517, your calculator is 0.99. Well, that is really, really, really close to, I call that 2. Okay, you divide this one, my calculator is 3. That is really, really, really close to 4. So we're going to call that 4. How close do you need to be to call it that number? I would say like within, within hundredths of a whole number. If this was 1.8 and this was 3.8 or 3.7, then it would be in it. Like the division usually gets you to the point where it's either you're going to call it a whole number or you're going to have to do some multiplying. That is almost 2 and that is almost 4. So we're going to end it there. 2, 1, and 4. I don't need to go on and do the next step because I don't have decimals anymore. These are whole numbers. So we're going to put them in. This went with K. I like to put my substance in my problem so I can see who it goes with. K is going to get the subscript 2. CR is going to get the subscript 1. And then O is going to get the subscript 4. So there's my answer. The formula would be K2CrO4. Okay, the next problem that I'm going to do, I do not have on your paper as an example problem. It is actually down one of your practice problems. I wanted to do one for you where you had to multiply, and I worked problems until I found one that worked out like I wanted it to. So this one is your number 4 on the sheet. I'm doing it with you. So we do the same thing. We're going to repeat those steps. The first thing is to use these percentages up here as grams. So we've got 29.1 grams of sodium. We have 40.5 grams of sulfur and 30.4 grams of oxygen. Step 2 is to convert these to moles. And part of what you do with these problems is you have to memorize the steps. You're going to have to memorize what to do in order to get it right in the end. If you do enough of these, it becomes second nature. You're helping yourself ingrain it in your head. That's why I want you to do practice problems with it. If you can do one, that's one thing, but you're not going to remember it in, a couple of lessons. Okay, so there are 23 grams of sodium in 1 mole according to the periodic table. And that comes out to be 1.27. Okay. If you do 40.4 or 40.5 grams of sulfur, there are 32.1 grams in a mole into the periodic table. You do the math of that, you should get 1.26. 30.4 grams of oxygen, and there's 16 grams in a mole according to the periodic table. That gives me 1.9. Now, I keep cutting my screen. Apparently, it's skipping ahead. So these are all decimals, and I would not go to multiply. This is too far away from 2. I think it ended up being exactly 1.9 in the calculator. So that's not just a couple hundreds. It's not like 1.98 or 1.99. I'm not just going to round that up. But what I'm going to do is I'm going to divide them all by the smallest. The smallest is the 1.26. So what you do to one of these, you must do to all of them. So we're going to divide them all. Okay, so as you can probably figure, this is going to be very close to 1. This is exactly 1. And this comes out to be 1.5. So now, I told you to use these as your subscripts, except there's a problem. I cannot have 1.5 atoms of oxygen. So when you have something that ends in a half, if you double it, it will make a whole number. But if I double this one, I double all of them. That's what I just told you. What you do to one, you must do to all. So this becomes 2, this becomes 2, and this will become 3. Those are whole numbers. I may use those. So I will have Na. Na is right here. It goes with 2. So 2. S is the middle. It gets a 2. And this is an O. O gets the 3. So my empirical formula is Na2S2O3. Now, if this was 1, 1, and 0.3, remember I told you on the first slide that, 0.3, you would multiply by 3. If this ends up being 0.75, then you would multiply by 4. So keep in mind with the fractions that depending upon what it is, you're going to need to multiply. Most often what I see is something that ends in a half. Okay, now, you have practice problems with this. You have 11 of them. You can either stop right now and you can work those practice problems, and then you can come back to the video. If you do that, I have a little thing in your notes that tells you when to stop and come back to the video. And if you would rather, you can go ahead and finish it and then just work all of the problems at once. We have one more thing to do. Okay, talking about molecular formulas. Okay, remember that molecular formulas are multiples of the empirical formula. And so I usually use like EF and MF or MolF and EmpF, like some sort of abbreviation to represent empirical formula and molecular formula. So you can have empirical formulas that are also the molecular formula. So like CH2O is an empirical formula and it's a molecular formula. But this right here is another molecular formula of this same empirical formula. This is also another molecular formula of the same empirical formula. This one, everything's been multiplied by 2. It's C1 has become C2, H2 has become H4, and O1 has become O2. This one, everything got multiplied by 6. So C6, H12, and O6. All right. What we can do is we can find the compound's molecular formula given some information. Okay, we know that the compound's molar mass has to be a multiple of the empirical formula if the formula is a multiple of the empirical formula. So here's what we're going to do. We're just going to divide to find out how many times we need to multiply. That sounds crazy. Let's see what we're talking about. So the first thing that we need to do is look at it. It says if the empirical formula is this and the molecular formula is this, what is the molecular formula? So kind of like I told you before, some steps over here. The first thing that you need to do is to find the empirical formula mass. Find the mass of this thing. So it's either the mass of H2O. So 12 1 16 equals 20 grams. Now, what we know is that the molecular formula is some multiple of the empirical formula. So we're going to molecular formula mass by the empirical formula mass. So we're going to have 106 divided by 29 grams equals an even 4. It should always be an even number. These won't be decimals like the last time. This 4 tells me that the empirical formula is a fourth of what the molecular formula is, or the molecular formula is 4 times what the empirical formula is. So our third step will be to use the answer to number 2 as a multiplier. So we are going to take the empirical formula, which is CHNO, and we are going to multiply everything in it by 4. So C1 will become C4. H1, there's understood ones here. H1 will become H4. O1 will become O. There, my molecular formula. That's all you're going to do with it. My students tend to think that these are pretty simple. I'm hoping that you'll think that they're the same. You have practice problems dealing with these as well. So if you have stayed with me the whole time, it is now time to stop and practice everything. And if you did the other set first before watching this one, well, you have a few more to do and you are done.